Hey, looks like I'm live. Hey, how you doing? Cameron Thomas from Heads Up Weather. So, hey, I figured I'd just go live today since we have a big old snowstorm coming our way actually not big old snowstorm. That was actually kind of a throwback to a really funny weather guy down in North Carolina, Mark Mathis. Look him up. Weird guy. But anyways, we have a snowstorm coming in tonight. I just figured we just do a live video, and I'll just kind of cover everything that I look at as a weather guy to determine a snow forecast. So we'll get right to it. I'm already sharing the screen here, and I will try to monitor uh, questions or comments. So feel free to post them in the link below or wherever it is on your screen. I have no idea. I don't even know what I'm looking at right now. So hopefully you can see my screen with all these bright, vivid colors. So basically what we do is we look at the overall pattern from a bird's eye view and then drill down to the surface level. And then we go through all sorts of analysis and figure out what's going on. But really, what's the big setup that we have for the snowstorm? Now, for the past week or two, we've been watching a trough of low pressure building in across the central and eastern third of the US, okay? So, one of the main ingredients for a snowstorm is you need cold air. Well, where is that cold air? It's up in Canada and the Arctic. How do you get that cold air down here? Well, it's through the jet stream. So, you have all these waves in the jet stream. The jet stream, we're looking at the 250 millibar level chart. This is where the jet stream is about 25, 30,000 feet up. So these are the high winds that really drive the weather systems. Now, there are all sorts of troughs and ridges and waves, long wave troughs and ridges, short wave troughs and ridges embedded within the long wave pattern. So there's all sorts of stuff going on right now. This is the subtropical jet right here. We have the Arctic jet coming down from Canada. There's even a polar jet way up there. But this is generally what we look at first to get an overall idea of what's going on in the upper levels of the atmosphere. So right now we're going to go back in time a little bit. We're going to back to about Thursday just to see how this starts setting up. Now, what I want you to do is look way up in Canada, like Alaska, Canada, Western Canada, was at the Yukon, and then watch this ridge build in. A ridge is going like this. It builds in like this. So watch that build in. So what happens is winds around a ridge are clockwise. They go around like this. So see, this is a northerly or a southerly flow. This is coming from north to south. These are northerly winds, the direction from which it's coming. And then it's pulling that air down from Canada. That's the first ingredient that you need to get the cold air into the central part of the US. So that's generally what has been happening. So this is right now. This is a timestamp right now, Sunday morning, okay? So again, let's look at this again. Watch that ridge of high pressure build in. Then this trough of low pressure digs into the central part of the US. That's good. So that's a general indicator that, okay, something's happening across the eastern third of the US. We want a trough of low pressure, generally across the Mississippi Valley. So that's a good thing. And now as we go through time, now from now until tomorrow, then we start going through this time, the jet stream. Within the jet stream are these jet streaks or jet maxima. Those are the areas of highest winds in the jet stream. Now, within these embedded jet streaks or jet maxes are areas where divergence aloft is more susceptible to help pull storms, pull air from the surface upward. So those are the more the stormier parts of the jet streak. So we definitely have that area coming across the northeast. So I won't get into too many details right now, but generally we're looking at that trough of low pressure across the eastern third of the US. Now, what we're going to do is going to drill down a little bit further into the atmosphere. Now, this is the 500 millibar chart. These are constant pressure charts. So 500 millibars, but then these contours are basically the elevation of that pressure level. And now this is the trough of low pressure. This is the ridge of high pressure. Again, it's getting into too many nuts and bolts there. But again, this is about 18,000 feet. So 18,000 feet is sort of like an average of the atmosphere. While we were looking at the jet stream aloft, way up high, this is kind of like an average of the atmosphere. This kind of just helps us visualize where those troughs and ridges are. Because, there's a lot going on there. But this kind of streams it out a little bit or smooths it out a little bit more. So we're going from right now, this is a time period right now, and then we're going to go through today and into Monday. See this trough of low pressure? That's the cold air. That's what we need. Okay. Now, there are also other indicators, other pattern setups that we look for. Now, I've talked about this before, the North Atlantic Oscillation, which is basically a high pressure area over Greenland. We do sort of have that. It's a little bit further south. Sometimes we like to see a low pressure over here east of Newfoundland. But as I alluded to before, we love to see that ridge of high pressure over Alaska. Again, that pulls that air down here. That's a good setup. A ridge over the Pacific or over the West Coast is good. That's the Pacific North American Oscillation, so that's a good indicator as well. Those indicators are sort of neutral, kind of weak to neutral, so no big strong signals like that. But hey, the biggest signal we have is this trough of low pressure. Now, what I'm going to do is go even further down to the surface level. This is the 850 millibar. This is about 5,000 feet in elevation. This is more of an indicator of the surface air that's coming through. So again, while we have this trough of low pressure digging into the eastern third of the U.S., here's that cold air closer to the surface. Now, another thing we look for when it comes to East Coast storminess is that frontal boundary. So this is the boundary between cold air and that the tropical air down here. So we look for disturbances along where that frontal boundary is. It's not always here all the time. It's always, it fluctuates. It goes north and south, east and west. It fluctuates. But when it's down here, we look for surface level disturbances to develop. And then what happens is then we have what's called vorticity, which is, again, back up to about 18,000 feet. This is the spin in the atmosphere. Spin generally is conducive to storminess. Helps with unsettled weather. Now, when this moves over that surface level disturbance, that enhances storminess even more. That goes back to Pedersen's rule. I covered this probably a few months ago. Pedersen's rule is when you have a surface level disturbance down here along the Gulf Coast or anywhere, then you have an upper level disturbance go over that. What that does is helps pull the air from the surface even further up through the atmosphere and develops even more storminess. So that's Pedersen's rule. And that's basically what we have. That's why we've been looking along the Gulf Coast, or at least we always look down here to see where that storminess is developing. And then as that trough of low pressure, this is the general path of that storm. If it comes off the East Coast, that's good for us to get East Coast storminess. So those are the pattern recognitions that you tend to look for, a week or two out. And you also have to look at the trends as well. You can't just look at one model run and then all of a sudden there's a trough of low pressure across the East Coast. Has it been there consistently day after day after day or week after week? If that's reflected in the models, then the confidence level goes up that this is going to happen. But oftentimes models will fluctuate, they'll go back and forth. Sometimes they'll show storminess or a trough or a ridge, and then next model run, it's gone. So those are the things you have to look for. It's a consistent analysis. You can't just pop into a model run and say, oh, this is going to happen. No, you have to look at the trends and see if that's consistent day after day. Now, again, we're going to go closer to the surface and get into more details here, but that's generally what we're looking for, okay? So with this cold air, that settles in or really digs in for this upcoming work week with that bitter cold air. Though we're talking about the storm right now, okay? So this is the vorticity chart, okay? So going ahead in time, this is where that storm is tracking, and then it comes across us. Okay, so things are looking good for a snowstorm, okay? And it has been for a little while. Now, also, what we look at is vertical velocity. So this is actually, I wanted to go to 700. 700 is about 10,000 feet. So you're basically looking at all levels of the atmosphere. Do you have that upper level disturbance curling through? Do you have that mid-level vorticity coming through? Do you have that surface level disturbance developing? And then the other levels of the atmosphere, does that have vertical velocity, that upward lift to really enhance storms? So you look at all the levels of the atmosphere. Now, again, blobs, pretty colors and everything, but this is generally showing vertical velocity. When you get air to move upwards, that's unsettled weather. That's good for storminess. If it's moving down, that suppresses storminess and you get generally better weather or clearer, drier weather. So this is the upper level. You have a lot of it over here, okay? So we definitely have vertical velocities coming through the area. Focus mostly across southern New England. That's pretty consistent. These are the different models across here, but this is a certain timestamp. We are looking at, actually, this is for tonight. I'm going to go ahead. This is when the storm is rolling through, okay? So generally speaking, you have areas of that vertical velocity coming through. So you can just sort of eyeball. It's like, okay, it's pretty much across southern New England. So that's generally where the most uplift, the most precipitation, the heavier the snow is going to be. Okay. So that's the 700 millibar. You can also go down to the 850 as well, and just to kind of cross-reference that and make sure that all levels are reflecting that. And here as well, you have that up vertical velocity, that upward vertical motion. Okay, so definitely things are coming into or falling into place for a storm. Now, what we're looking at is more of the exact track. Now, again, you can't just look at a model run on any particular day and like, oh, hey, we got a big old storm. The GFS indicated that a while back, and it's like then it was gone the next run. Okay, those are the trends you have to look at day after day after day. So what we're going to look at now, the past day or two, the models are coming more in line or becoming more consistent with their track. Now, again, some models were a little further offshore, some were a little bit further inland. So what do you choose? You have all this data coming at you and you're just trying to figure it out. Sometimes you can have these models say, all of them saying, yeah, we're going to get pounded by snow, or hey, this one's going to completely miss. And then within like maybe a day or two, sometimes it can shift dramatically. In fact, we had that last year. With that snowstorm that was going to hit Boston and then it moved too far to our south to really get anything. It happens, okay? But generally, we've been looking at the consistency in the models for the past day or two, and this is generally what we're looking at. So I'm going to stair step our way through this particular model. This is the GFS model. This is the US model. This is the European, okay? So you have to have a lot of windows open, okay? So bear with me, okay? I know I jump around a little bit. So this is the GFS. Now look at the timestamp over here. This is the local timestamp. So this is this morning. And then we're going to go through time. Now this is, 7 o'clock tonight, then the storm. Generally goes across pretty close to our benchmark. And what do I mean by a benchmark? It's the 4070. Yeah, it's pretty much dead on. 4070. Those are the lat long coordinates for where you want low pressure to go if you really want to get hit with a snowstorm. And it's just off of Nantucket Martha's Vineyard. So right about there. So you can see here we go, 70, 40, 70. So right about there. Hey, pretty close, right? So that's why we've been alluding to this storm becoming more and more likely, okay, because it's pretty close to that benchmark, or at least for southern New England, because as you know, a lot of these storms have been tracking, through New England. And what happens is it pulls in this rain too far inland, and then it pulls the heavier snow across northern New England. So, hey, if you're northern New England, great. Hey, that's bonus for you. But most of these storm tracks have been through New England. And then as of late, the storm track was too far to our south. So remember last week, that storm just a complete whiff went way out to sea. So, hey, we finally got our chance here with a storm track just offshore. So, what we're going to do is we're going to stair step. So, now, as you can see, we're going through 6-hour increments here. Okay, that's what the GFS does, 6-hour increments. So it's arriving about 5 or 6 tonight, 7 o'clock, and then it goes through. The heaviest is overnight, and then really by daybreak, then this thing is pretty much winding down. So when I look at these things, it's not a terribly strong wrapped up storm. It's not going to just stall, spin, intensify, or bomb out. I'm sure you've heard of bomb cyclone, which are low pressure systems that deepen 24 millibars in 24 hours. This is not the case. This is your garden variety storm, nor'easter, because we technically still have those northeasterly winds. This is technically a nor'easter, but it's not terribly strong. So within about 6, 7, 8 hours, this thing is in and out of here. So generally speaking, the snowfall that can happen in that time period is about half a foot. That's generally what I've seen. That's kind of like my benchmark. And now it just depends on where those smaller mesoscale bands set up. And we'll take a closer look at that. So this is the GFS. So as you can see, looks like the heaviest is across, southeastern New England, and then it tapers off closer to the Canadian border you get. Okay, so we're kind of narrowing down those heavier snow bands and seeing where the heavier snowfall is going to be. I'm going to take a peek over here to see if there's any questions popping up. Got these windows. Okay, I think there's a couple comments. Again, bear with me. I'm just trying to see if I can access all these pop-ups. Stop with the pop-ups. Okay, I'll get over to the questions here in a second. if I can figure out where those are. Come on, where are the comments? Oh man. Sorry about that, guys. I'm still not the best at this Facebook Live. God, it's a pain just to try to get it started. Come on, comments, view insights. Maybe if I need. Anyways, are you guys still seeing the screen? Hopefully you are. Just bear with me. Bear with me. 12 comments. Anyways, all right. I'll figure that out later. Okay. Back to the storm. So this is the GFS. Now this was showing the most robust result or model run. Okay, it was the closest inland. There were a couple others that were even further inland, but the GFS was pretty consistent with it showing a pretty close track to the benchmark. The European model, now that has been consistently a little bit further offshore. As you can see, it's pretty close, but really the past few days or past week, it was showing it a little bit further offshore, but that's come in line a little bit more with the GFS. So these are the trends that you got to look at. So now we can pretty confidently say that this thing is going to track close to the benchmark. We're going to get a little bit of the rain across the Cape and then the heavier snow bands across central, southern New England, and then less further north. So pretty confident in that. And again, the timing is pretty similar, in and out of here overnight. Okay. Now, the big question, all right, how much are we going to get? Now you got to look at the moisture. Now, there's another thing you can look at, these ensemble runs. These are basically multiple runs of a model. This is the US model. They run a bunch of model runs, but just slightly change some parameters to see if you get a similar outcome with just slightly changing things a little bit. And then you average those out. And this is what the short range ensemble forecast looks at. Now, this is a QPF, okay? Right up here, QPF. This is the quantitative precipitation forecast. The QPF generally shows how much moisture is in the air, okay? So what models do is it analyzes a column of air, sees how much moisture is in there, and then it calculates how much could fall in that column of air. Not saying it will, it could be more, it could be less, but this is an average of how much moisture, how much precipitation within that column of air. And then it averages out across the area. So what this is showing, again, this is an average or the ensemble run. Now, I look at this to see generally where the precipitation is going to fall. Now, as you can see, like what we just saw, the heaviest looks to be across, southern New England, and then it tapers off further north, and then some really heavier bands here. But then again, you got to think about the rain mixing in here, okay? So, and then when you're looking at the amounts, lighter, the greens, the heaviest is like the darker green. So 1/4 of an inch to maybe 1/2 an inch. Okay, so 0.2 to 0.5 inches of precipitation. That's liquid form. Then you got to convert that to what that is in snowfall. So typically, an average snow ratio is 10 to 1. So for 0.25, you'd be looking at 2.5 inches. 0.5, 5 inches of snow. But then you got to figure out, well, is it going to be a 10 to 1 ratio? That's average, but if it's warmer out, if temperatures are closer to freezing at the surface level, you might bump that down to 5 to 1, much less. Then if it's drier, fluffier snow, colder air, then you might bump it up to 10 to 15 to 1. Or maybe if it's really dry, maybe 20 to 1, okay? So that's sort of what you have to take into consideration as well. Since it's going to be colder, you look at the surface level temperatures, kind of give you a general idea what that's going to be. And with temperatures in the teens and 20s, you're looking at 10 to 15 to 1. But then you also look further aloft to see where that snow is being generated aloft. We can take a look at that. Actually, let me cover that a little bit more. We're really going into the nuts and bolts here, okay? I'm going to click into this. Now, what this does, it gives you, this is called a skew T. This is a cross section of the atmosphere. Now, it looks like a mess right now, but this is the temperature in Celsius degrees. These are the millibars, the different levels of the atmosphere. Again, 500 was about 18,000 feet. 2 to 3, this is where your jet stream is, but then we're down here at the surface level. Now, the red line is the temperature. These are the sounding balloons that the Weather Service puts out. They throw them up, twice a day, 4 times a day, and then it calculates the temperature, pressure, and all that stuff in the winds. Then it puts it into a graph form so you can analyze that. So the further up you go, the higher in the atmosphere you go. But the red line is the temperature. The green line is the dew point. When they're close together, that means it's saturated. That means you're getting precipitation here. But I also want to look over here. This is the DGZ. DGZ is for dendritic growth zone. This is where the snow develops, okay? Depends on what temperature it is here. The colder the temperature, snowflakes have different shapes. So within certain temperature ranges, it has a different shape. Sometimes they're more platelets, sometimes they're columns. But if you really get the big dendritic snowflakes, your big fat snowflakes, the typical ones that you're carving out of paper and everything, that's your dendrite. So within certain temperature ranges, you get that dendritic growth zone, the bigger, fatter snowflakes. So there are prime zones for that for the really heavier snowfall. Again, I'm getting into the weeds here, but this gives you an indication of whether it's the snow ratio. So that's why I'm kind of leaning towards like maybe a 10 to 15 to 1 snow ratio. Okay, that was really getting into the weeds. All right, so, okay, your eyes were glazing over, I'm sure. Where was I going with this? We can look at the snow amounts, okay? So let's get into it. So this is another model page. This kind of shows the snow level charts or the snow amount charts. Again, this is QPF right here. I'm going to get over to the snow. Actually, I had that up in the snow. Here we go. I know I'm bouncing around a lot. This was the QPF. Remember, I called that the quantitative precipitation forecast. Actually, here we go. This is basically across most models. We're looking at the same thing, about 0.2 to 0.5. Okay, so that's the general range of liquid precipitation. So then again, you convert it to snow ratios. Now, let's look at the snow. Okay, these are the different model outputs. Okay, this is for Monday morning. 12Z is Monday morning, and then these are all the different models across. I'm not going to get into each one. GFS is the US model. ECMWF is the European model. If you just do a quick sweep through, you can generally get an idea, okay, where's that heavier snow band going to go, okay? And I think we're pretty confident to say that, pretty much central and southern New England is in the jackpot area. But again, we're not looking at huge amounts, okay? Generally less than half a foot, okay? I'd say right around half a foot for most of these. And again, you've got to look at the model trends. What have they been putting out day after day? Has it been pretty consistent? Is this one model run just an anomaly? Okay. Have they been pumping out, 5 to 10, maybe a foot of snow, and then all of a sudden it's down to half a foot? No, it's not the case. It's been pretty consistent. We're not going to get a huge dumping of snow, but there is a chance of getting some good fluffy amounts, across central and southern New England. So, that's why I've kind of made my snow map where it's very little up here, and then you kind of graduate the bands or the zones into heavier amounts the further south you go. So we're looking at that. So again, I'm not going to get into every single model here, but that's kind of like what we're looking at. I'll get over to my snow map here in a second. As far as timing, LM, I don't know if you're on here. I know that you were kind of looking at the timing of everything. And again, I'm just trying to get back over to where the comments might be. I'm so sorry, guys. Total comments. Where are the comments? I don't want to back out of anything because I'm afraid it's going to stop it. So I'll wait till the end. So this is the high resolution rapid refresh model. This is sort of like your last minute, kind of really high resolution, kind of radar estimates of what it's going to happen. So you can, and these are in hourly increments too. So much more detailed than the 3 to 6 hour increments that you get with the other models. So I'm going to run through this so you can get an idea of the timing. Okay, so all day today, pretty good. The clouds will increase. Then by, 4, 5, 6 o'clock, then we're starting to look at this light snow develop. Okay, so this evening. So after the sun goes down, it's going to start snowing a little bit. And then it's going to develop. The heavier snow bands are going to develop across central and southern New England, a little bit of the rain and some mix across the Cape and the islands. And then the heavier bands start to wind down, and we're looking at tonight, 10, 11 o'clock tonight, it's already starting to, kind of thin out a little bit. And then, by 2 in the morning, 2, 3 in the morning, maybe 3, 4, 5. So as we're waking up tomorrow morning, then it's going to be kind of all done. Okay. So again, a pretty quick moving storm. So I'm not going to go for high amounts. I'm not. I think it's generally going to be about half a foot, give or take, on either side of that. But again, across central and southern New England, some heavier bands could set up, but not a whole lot of time for it to set up. We're not getting a huge onshore flow and getting a coastal front to move in, which enhances snow. We're not going to get it totally wrapped up with hours and hours of intense snow. This isn't that storm. This is going to be sliding in, slide out, and then it's out to sea, and we're done. So looking at, I'll bring over my snowfall map. I'm going to modify this a little bit today. I know I've been a little bit, my categories are still changing. I'm just trying to find some fun categories. I'm not going to do the number game. I mean, other channels do that, and it's just it's a mess sometimes. People quibbling over, inch two or inch or here. It doesn't matter. We're just trying to get an overall idea, like what are the impacts. Now, generally, I say the nuisance snow is like you're looking at your coating to maybe an inch or two up here. I might switch these categories a little bit, but then we're looking at like I said, about the White Mountains. Southward is where you're going to get the heaviest snow bands. I might call this the small shovel. Let's do that. Small shovel. Okay. You're looking at 2, 3, 4 inches of fluffy snow. You probably sweep it away if anything. And then the heavier snow bands. I'm debating between maybe big shovel. I'm debating of either swapping, maybe even getting rid of stay home. I think we're all going to be staying. It's nighttime. I think we're all home anyways, so I might change that. So we'll call the purples or the fuchsia. Is that fuchsia? We'll call that the big shovel. And then I tried to highlight some areas where it might get a few bands, maybe some heavier pockets. That's why I tried to just gradually shade these in for some higher amounts, maybe just above half a foot. Okay. So again, I might fiddle with these categories, but that's generally what we're looking at here. Covered the timing, the amounts. Again, I'm going to try to get over to the comments now if I can. Now I have to back out of a screen. So if that ends the live feed, which I hope it doesn't, it shouldn't. I just don't know how to get dashboard. Maybe that's what I need. Hey, I got back to my dashboard. Hey, look at me winning. I want to look at comments, but I don't know how to get to comments. I'm sorry, guys. I'm having trouble seeing where those are because it's a totally different screen when you're looking at the live feed view. It's got all these settings and Oh, wait, here we go. Okay. Sorry, David Anderson is way over on the right. I'm looking at the center of my screen. Yeah, David Anderson. Hey, morning from Wilton. Good. Yeah, that'd be great if you want to send your snow totals. Yes, I would probably say about half a foot. 3, 6, something like that. Again, a few heavier pockets would probably be right on that border there. Let's see. Anybody else? I'm just scanning through. And I'm not sure, LM, I know we were chatting before. I'm not sure if you popped on it at one point, but yeah, we covered the timing. So again, tonight, pretty much when we're, heading to bed, the snow will be falling, and then in the morning, we'll be cleaning up. So thankfully, it's a light, fluffy snow, but at least we kind of went through, what we look at as forecasters. You have to look at everything. I went wide view, looking at all the way from the Pacific to the Atlantic here. You drill down into the atmosphere at the different levels to see what's going on. Vorticity. Then you look at vertical velocities. And then you look at the actual surface level track of these storms. And then you have to compare the different models and then compare them over days and weeks and see if the trends are consistent. Because the GFS, I mean, probably about a week and a half ago, I mean, it was showing a massive storm and then all of a sudden, poof, gone. And then, a day or two later, it's like, oh, we're on for a big storm. And then it was gone. So that's what these models tend to do. You have to take it with a grain of salt. Don't look at a model run like a week out, week and a half out, and like 280 hours out. Hey, we're going to get a huge snowstorm. Don't do that. No, GFS is notorious for doing that. Some of these models do. And then next thing, it doesn't happen. Even some of the weekly models, there are some ensemble forecasts that do weekly and even monthly forecasts. And what they do is they try to average out what on a weekly basis, what is that overall pattern going to be? Is it going to be cold here? Is it going to be warm there? And even those can flip. Oftentimes you'll look at a week or two out, forecast, and then that time comes and it's completely opposite. So the models are they're not right all the time. They definitely help, but you got to take a lot into consideration. But again, we kind of went to the surface level, look at some of the high resolution short range ensemble forecasts to see if if the average of all these models are really panning out the way they are. Then you look at the the liquid output, and then you try to come up with the snow ratio, and then you look where the snow bands are going to fall, and then you just try to come up with your own forecast. A little bit how I forecast is that I try not to look at anybody else's forecast. There are times where I just can't help it. I watch WMUR, great forecasters there. I know some of them; they do a great job. But it's inevitable. We watch the news; it's going to be on. But I try not to look at any forecast before I do my own. And even then, even after I do my own forecast, I don't even want to look at anybody else's because I want to just do my own. I don't want to be influenced by other forecasts. That's called, in my opinion, that's forecast integrity. I do my own analysis. I look at everything on my own. I come up with my own forecast. These are not computer generated charts. These are my own crappy hand drawn charts. I am not a map maker. My time in weather was paper forecasts, text forecasts, and radio forecasts. We didn't do graphics, so I don't do graphics. This is my first time doing graphics. I'm horrible at it, but hey, you don't need. There are a lot of great graphics out there, and kudos to those who make them look really, really good. I'm not that guy. Okay, maybe someday I will, but not right now. Um, but that is forecast integrity. I don't want to be influenced by other forecasts. Um, that's just the way I roll. Okay. Um, Also, another point I want to make is that we do have this cold, cold air setting in for the long haul. That was the other big story. This bitter cold setting in for the first part of this week. It gradually warms up, relatively speaking, back into the 20s for later this week, but it's going to be cold. So, what that means is that any snow that falls is going to stick around. Okay. So sweep it away, get everything clear, but also clear it off your roofs. If you get a decent amount of snow, try to get it off of the edges of your roof. And the reason for that is because it's going to be cold, it's not going to melt, so the snow is going to stick there all week, okay? But what happens is if you don't have good insulation in your roof, it allows heat to come up into the roof and melt the snow from underneath. And it melts that snow, and then it drips off, and then it freezes in the cold air. That's when you get the big icicles and those ice dams. So you don't want that. It creates a lot of damage. We had it happen to us, and it created a lot of damage. We had to get it fixed. But just if you can if you can reach up and sweep off, just even on the edges to where it can just drip off and not refreeze underneath the snow at the edges of your roof or in the gutters or anything like that. So it's just one of those things. So hopefully that helps. We covered quite a bit. I know I've been rambling on for, I don't know, wow, about half an hour now. But I will try to just adjust this forecast. I'm not sure if I'll change this very much. I might just change the categories a little bit. But again, generally speaking, a half a foot for the heaviest areas. I would say half a foot for this pink, purple, fuchsia zone. Maybe a little bit above half a foot for the red. But that's generally what it's looking like. And a little bit of rain for the Cape and everything. So I'm gonna look. Anybody else? Any other? Any other questions? Anybody? Anybody? Bueller. I think I will call it good. So if you have any questions, this will be posted. And if you have any questions, post them in the comments, and I'll be happy to answer them. So hope that helps. Cameron Thomas at Heads Up Weather. Enjoy the snow, everyone. Take care.